Hi guys, welcome back. I think you can hear me. Quickly confirm whether everything is audible and visible or not. Yeah, cool. I think it's clear. So in this lecture, we're going to see uh, transducers. Instrumentation part, it's a part of instrumentation, transducer questions. So these are simple questions, okay? If you can quickly answer to those questions so that we'll be able to quickly go through all 25 questions. I think we have here 25 questions, okay? So let's get to the first question. First question, yes, here you go. First question on the screen. Timer is running. Quickly answer to this. I think 1 minute is actually high for this, but yeah, you take 1 minute time. Our objective is not just answering a question, it's also to understand about this question. So most of you answered it. B. Yes, it's a transducer. So within a time that because we're wrapping it quickly because there are theoretical questions. They are the theoretical questions. So we'll quickly go forward within a minute itself. You try to answer, I'll try to explain and go forward to the next so that we'll be able to cover all 25 questions in one shot. Okay. Yeah. So that transforms one form of energy into another form of energy. It is called transducer. That's what the key difference between a transducer and a sensor. Sensor just senses something. Transducer will have within that, it will have a sensor. Along with that, conversion principle is also there. That's what we call it as a transduction principle. Okay. So transducer is answer. Good. Let's go to the next question. Yep. We have something. Raj is asking something in the chat. If somebody can answer, try to answer this question. What is asked by Raj? I'll share my opinion also on that. We'll take up these kind of extra questions at the end of the session, not in between the session. Okay, so try to go with the session first. Yes. Great, I think most of you answered it, so I'm just going ahead with my explanation. Which of the following converts a physical parameter to an electrical signal? So transducer, we have just seen transducer, which converts one form of energy into another form of energy. If that other form or any one of these forms is related to electrical signal, then it is called as electrical transducer. Transducer is not necessarily electrical transducer. It could be mechanical transducer, it could be chemical, it could be optical, it could be anything. If it relates to electrical signals, then it is called as electrical transducer. And of course, most of the transducers are dealing with electrical signals. Okay, most of the transducers what we use in industries. So a transducers means by default, one will try to consider it as electrical transducer, but they are actually different. Okay, but yeah, as we are mostly used onto this, so you can call it like this. And one more thing, what do you think? What's the difference between instrumentation and measurement? This is what the common question. Instrumentation measurements are the same or different? Do it in the comment. Okay, I'm going to the next one. Next question. Here you go. And guys, for the job updates, there are notifications are coming up very quickly. Notifications are coming up regarding the updates, how to prepare, how to strategize everything. All are given in the WhatsApp channel. Our WhatsApp channel is pinned in the chat in the description. You follow that, you follow that chat, or you follow the channel, so that you'll get the regular updates on that. You'll be staying updated with the content, with the updates of job and everything. Private jobs. What is private jobs? It's all, whether it is a government jobs or private job, whatever it is coming into our zone, we'll try to pass on to you through that channel only. Tarun. Yeah, I think electrical transducers generate dash. Obviously, it's a simple thing. Electrical transducer, just now I said, electrical transducers will be dealing with electrical signals. Okay, so they will have electrical signal. Okay, answer is D. Go to the next question. Exam dates, dear, as we said already earlier, I said about the TSGENCO exam dates. It's going to be in the last week of that Jan month, and it is not yet officially given. It may be, we just guess, just we're guessing it. Okay, but suddenly they will not give you a huge time again, 2 months time for you. Okay, stay prepared, continue your preparation, polish and shine your preparation. Okay, if you don't do that, you're gone case. Okay, you'll be in a big trouble. I think this is a simple question. Everybody answered it. Transducer must have dash input output characteristic response. Definitely linear input output response. Means if there is some change in the input, its corresponding change must be there in the output, in the response. Okay, and should be linear. It should be linear. Output to input relation is linear like this. Of course, it's hard to achieve such linear characteristics all the time. So what you'll do is you'll pick the linear zone of operation, and in that zone of operation only you will just operate. You will try to operate. You will limit your operating range within the linear zone of operation, linear zone of characteristics. Okay, these are simple questions. Based on the transducers, you will not get hard questions. You'll get only simple questions, and you should be able to ready for those questions. Okay, great. Moving to the next question. Control systems sessions చేయలేదు. Let's do it. Let's do control systems. You have not asked for it, we have not done for it. And I think in the PiSquare's channel, PiSquare's app, if you see, control systems is one of the finest courses, because we developed a lot of apps for you to visualize the control systems. Nobody ever done that. Okay, you can watch our YouTube video itself, YouTube free videos itself, our control systems PiSquare Academy, search for it. You'll get some amazing animated videos just for free. Okay, or download the app. In the app also you will have some free videos. Enjoy those videos. Okay, the time's up. What is a potentiometer used to measure? What is a potentiometer? Potentiometer transducer. Potentiometer transducer. I want everybody to answer. How many terminals this potentiometer transducer has? How many terminals it has? Come on, in the chat. How many terminals it has? Number of terminals. Sweetie is saying 2, Praveen is saying 2, but sadly the 2 is not a right answer. It's 3. It is 3. Okay, potentiometer is having 3 terminals. Potentiometer transducer. See, what is this potentiometer transducer? I already explained this in the course with the nice animations and experiments also. Experiments were conducted onto the measurements, and we animated also some of the things. Okay, so these are the 2 terminals. Potentiometer is nothing but a resistor with a sliding contact. Okay, now this terminal will be taken here. This is this kind of a 2-port network. 2-port network with 3 terminals. Okay, now you're moving this, so accordingly you're finding out the displacement. Okay, so by moving this you're finding the voltage, hence you're finding actually the displacement. Okay, so the answer is mechanical displacement is what we're going to find. Okay, and by how we are finding this mechanical displacement? By measuring the voltage. By By changing this slider, you're actually changing the position. By changing the position, you're actually changing the resistance. Hence, the voltage is different. Okay. And this is called as a linear potentiometer. What is that? Linear potentiometer, because the movement is linear. There is something called rotary potentiometer, which is one of the popularly used potentiometer. What is that? Rotary. A rotary potentiometer is a popular one. I think that will be the next question. Yes. Yeah, try to answer this. This is a simple one related to the previous one. Sampath has given 4 also correct. You cannot say 4 terminals. The potentiometer part is having 3 terminals. You're extended to 4 or 5 or 10. You can say anything, but in a way, you're also right, Sampath. Which the following is a common application of a potentiometer. What is the common application? Definitely the position measurement is a common application. Finding the position, that's what we said, displacement, position, that's what the common application for this. And yeah, I already answered this question, I think. I have already answered this question. We're at question number 7. A lot of questions are there. Okay, theoretical questions, all are theory questions. So yeah, it will be easy to solve. It will be easy to answer. You answered it nicely. Just now I said a rotary potentiometer. You're having a resistance, not linear resistance. You're having a resistance something like this. And this is a pointer, or this is a slider. You're rotating this, it will slide along this. It will rotate along this, and you'll find the angle. That's what the popular use case of the potentiometer transducer. Okay. Next one. Faster. I think you have already visited our site. There is a special offer going on. Till 31st December. I think you have seen that offer. Offer is when you're buying the courses, suppose you're buying a TSGENCO course. If you buy 6 months a TSGENCO course, you can check the link in the description, courses.pit.in. And when you buy 6 months a course of TSGENCO technical one, okay, so this one for 6 months, then you're going to get the non-technical part, which is worth of 5,000 rupees absolutely free for 6 months. Okay, so I hope you'll be availing this offer. Offer is not for unlimited time. Obviously, it's for a short time. 2 more days left. Christmas offer we're extending up to 31st December. Okay. See, guys, you're worried about your job, whether I'll get a job or not. What you should really worry about is whether I'm having the knowledge or not. If you're not having the knowledge, try to gain that knowledge. Go and get for it. Go for it. You have to worry for that, not for the job. If you have the capability to get the job, then you think about how to master your existing skills to get into that job level. Okay. Anyways, what is the basic principle of a potentiometer transducer? Variable resistance, simply variable resistance. Can somebody tell me what is meant by this piezo? Just the term piezo. What does this piezo means? Is it a pigeon? What is a piezo? Actually true. The piezo is a word which has come from pigeon. Greek word pigeon. Not English word pigeon. Greek word pigeon means press. What is that? Press or squeeze. It means press or squeeze. Hence the piezoelectric crystal. That's what somebody is saying, Tarun is saying. Piezoelectric crystal means when you are pressing that crystal, it will give the electricity. Piezoelectric, that's it. When you are pressing, piezo means pressing the crystal, piezoelectric crystal, it will give the electricity. That's what a piezoelectric effect. What is piezo resistance effect? Piezo means press again. When you are pressing it, it will change its resistance. Hence the name piezo resistance effect. See how simple the name, if you just know the name, things are pretty much clear. Okay, so these kind of things, these kind of amazing things, we are discussing that in the courses. Okay, so yeah, you can try it out. Now, variable resistance is the one based on variable resistance concept. Potentiometer transducers are working. Okay, I think this point is clear. Let's go to the next one. Yeah. Note here, part A is separate, part B is separate. We have only technical parts. Okay. Just go to the app, you'll get it. All the full length tests are there for the technical part. Appear the test. We'll have the courses are having individual topic wise, chapter wise, all subjects. You'll have all different categories of test. So your practice, your learnings, your preparation will be checked at every point of time. Okay. Yep. How is the output of potentiometer transducer typically measured? Will not be measuring actually the resistance. Resistance measurement is not the one what we will do. We'll convert the resistance into voltage. We'll be measuring the voltage. So the measurement is happening with the help of voltage. We'll measure the voltage. Then accordingly we'll find out the displacement. I hope point is clear. Not B, it's A. Not even C. It's A. Careful with these tricky questions. Next one. Wow, you guys are moving much faster. This is the 10th question. You guys are amazing. Let's see who is how many of you go answer this 10th question. Okay. So sensitivity. Any sensitivity, not only for this potentiometer, for any case, sensitivity is actually speaking ratio of change in output by change in input. Ratio of change in output by change in input. In case of potentiometer, output is voltage is output, just now I said, and input is displacement. Position is input, displacement. So it is actually change in voltage by change in displacement. But according to the options, if I had to go, this is the only option which is relevant to this. So I'm going for option A. Okay. So Vijaya is saying AA 2 times. I think she'll have to make it twice all the time. Good. Anyways, I'm going to the next one. This is also easy one. Easy questions also take me this much of time, huh? Nice. So what is the range of potentiometer transducer? For anything, it's a range of any instrument. What is the range means? Range is simply for any instrument. Okay, if it is a voltmeter, range is 0 to 500 volts is range, 500 volt range, 500 volt range. So the maximum displacement that can be measured is a range. The maximum value, I think in your laboratory, and when you are giving a requisition form, when you are asking for instrument, you will ask for 500 volt range instrument, you'll ask for something like that, right? So range means the maximum displacement that can be measured is a range, simple one. This is not just true for potentiometer case, it is true for any instrumentation purpose, any measuring device. Okay. Next. Again, there is a pinned comment here in the chat. You follow the WhatsApp channel. Okay, there we are now coming up with MATLAB course, MATLAB and industrial automation, Arduino course. We are coming up, we're planning to come up with these courses. Okay, so all these updates you'll be getting in the WhatsApp channel. Just follow the WhatsApp channel so that you can take the benefit out of it. Okay. What is the resolution of a potentiometer transducer? This is true for any instrument, not just for transducer, but it is asking in terms of with respect to the potentiometer transducer. Resolution means the smallest change in the input which it can measure for any instrument. The smallest change of input which it can measure is a resolution. So here the input is a displacement, so smallest change in the displacement that can be measured is a resolution for a potentiometer. So going into the next question. That's what here, Sampath, don't give it here. WhatsApp channel, you follow the WhatsApp channel. There you'll get the course which is of your demand. Okay. Okay. What's accuracy of a potentiometer transducer? Accuracy, see, these are the common definitions. We are now looking at these common definitions with respect to potentiometer. Accuracy means it's a degree of agreement between the measured value and true value. If the measured value, true value are exactly same, it is 100% accurate machine. Error-free machine, error-free instrument, not machine. Error-free instrument. So it is the degree of agreement between the measured value and true value. How measured value, how close is the measured value to the true value is accuracy of any instrument. Okay, so we want 100% accurate instruments naturally. All questions answers are A, is it? Is it? Most of the questions maybe, I think. Tarun will see that. Why can't we? I'll just go back. Let me finish this. Then I'll go back to the previous one. Yes, Anvesh is saying correct. Anvesh, you're right. It's D. So what is the hysteresis of hysteresis? Hysteresis means delay. What is that? There is a delay in the response. Okay. And because of the hysteresis, what will happen is when you are giving some positive voltage, it will give its corresponding value. Same magnitude when you give negative voltage, because of the delay, because of the residual voltage, because of the residual flux, it will not show the same magnitude. Okay, the difference in output for the same input depending on the direction of difference in the output for the same input means there is a output will not be the same. Suppose when you're giving a plus 5 volts, when you're giving plus 5 volts, or to be more precise, let me put it this way. Not with respect to the question. In general, hysteresis means what? Suppose when you are checking any resistance value or voltage value or current value in the increasing order, when you are doing the experiment, maybe the response are like this, different values at different cases. When you're taking the readings, when you're joining all the dots, you might end up getting something like this curve. Now the same experiment, not with the increasing values of voltage or current, with the decreasing values of voltage and current. You have reached up to this, now you're performing the decreasing values of the voltage or current. Then ideally speaking, it should follow the same line, but instead it will follow a different line. Why is this happening? This difference means for the same voltage, current, it is exhibiting a different current when it is decreasing. This is called as hysteresis. This is due to the hysteresis. So in your laboratory, when you're doing perfectly, when you're taking the readings perfectly, you should take increasing order, then decreasing order. You should take the average of it to get the final value. But you don't care to do all of these. You'll just take only either increasing or decreasing. Okay, most of the cases you'll take increasing order. Okay. Yes, due to instrumental problem, that's what the hysteresis issue. So this is relevant to this. In the negative side also definitely the same is true. So the difference in the change in value is due to the hysteresis. That's what is this. Now for the previous one, Tarun is saying, why can't B? What is the accuracy of a potentiometer transducer? Accuracy is a degree of nonlinearity. Of course, see, hysteresis, nonlinearity, noise, they will all contribute to the accuracy. That is true. But what is accuracy means they're contributing to the accuracy. That is true. But to the question, yes, how close is a measured value to the true value is accuracy. You have to understand the question. Okay. I hope it's clear, Tarun. Moving on to the next question. In LVDT, do the core try to attain the minimum reluctance path? The core itself is a minimum reluctance path. Where is again a minimum reluctance path? Core is being that minimum reluctance path, right? Why? Potentiometer connect 4 to 30 milliamperes. Yeah, this is a good question. Subhash is asking something good question. Potentiometer case, we should make sure that current flowing in the potentiometer is minimum. Very good point he has raised. I'll explain once this question is over. What is self-heating? Oh, this itself is a point. This itself is a point, Subbu, for your question. In case of potentiometer transducer, only displacement, careful with this point, guys. He has asked a beautiful question. Displacement should only affect the resistance, should be ideally speaking. Okay. But what happens is when you are allowing, suppose 2 amperes of current here, suppose 2 amperes of current you are allowing, then there is some heat generated, I square RT. I square RT is a heat developed. Because of the heat developed, the resistance will change. Then the voltage will change. Even though position is here, with some time heat is generated, That heat is changing the resistance. That will affect the accuracy of the instrument. Though position is same, but voltage will differ. Okay. So to minimize that self-heating effect, we try to reduce the current. It's not 2 amperes or something. We'll try to give in terms of milliamperes so that the self-heating effect is less. Okay. What is the self-heating effect of a potentiometer transducer? The change in output due to the self-heating, absolutely, or change in accuracy due to the self-heating. You can also say that. Now here, this is an ambiguous question, you can say, because change in output due to self-heating will lead to change in accuracy. Okay, so now it's really tricky one to pick it up what is right. Okay, so according to me, both should be right. Both are correct. Okay, this will lead to the second one naturally. Okay, if you want to change the position of a damper of a fan, the power cylinder is connected to. Okay, so I think Tarun is also explaining maybe a point. Okay, next one. We're done with 15 questions. Okay, Tarun is saying we can only arrange 4 to 20 amperes. I think this question and previous question are pretty much linked. I'm expecting your answer. What happened to you all? Huh? Okay, you're using it in your duty. Good, good. Nice. All of you give that heart to Tarun because he's sharing his experience also. Okay. Like and heart for Tarun. Good. See, that kind of minimum encouragement should be there at least among yourself. I really appreciate that. Nice, guys. Nice, nice. Keep it up. Good. This is for all of you. This blast is for all of you. Okay. Those who are cheering up nicely. Yeah, coming to this. Which of the following is a disadvantage of using a potentiometer transducer? High resolution is not, disadvantage. High resolution means good resolution. High accuracy is not disadvantage. Low cost is not. Definitely non-linearity due to the loading effect. Loading effect is another point. Self-heating we have seen. Now what is this loading effect? Can somebody tell me? Just a keyword. What is this loading effect? Just a keyword. Here you are using maybe a voltmeter. Now this voltmeter will also have some resistance. And that resistance is not, if that is not so high compared to this resistance, then parallel combination of these two resistances will result to this voltage. So that's what the loading effect. Now in order to overcome this loading effect, tell me what should be done? Tell me what should be done? Yep. I'm listening. I'm looking at the screen, What should be done? Wow, what happened? Damping? High resistance voltmeter, that's it. If you use a very high resistance voltmeter, ideally speaking, infinite ohmic value of voltmeter, no loading effect. At least make sure that a 10 to 15 times of this resistance should have 10 to 15 times more than this entire resistance. So that loading effect will be reduced. If it is voltmeter, if it is ammeter, resistance should be low. Now in our channel, Bulbum ma'am has explained it nicely about why voltmeter should have high resistance, why ammeter should have low resistance. I think that's also given. Okay, you can just check it out. So answer for this is non-linearity due to the loading effect. Moving on to the next question. So I think Suresh is nicely saying current drawn by the device should be equal to 0 connected to the output. So if I just rephrase Suresh's statement, loading effect should be 0 means what? Power consumed by the instrument should be 0, which means loading effect is 0. Why analog input is used to connect potentiometer? Subbu, I think your question is not clear. Analog input means here input is displacement. Are you talking about that? You're talking about voltage. Input voltage, what you're giving. If you are talking about input voltage, what else you want to give? What else you want to give? Tell me. What is your options? Yeah. Coming to this, which of the following are the disadvantages of resistive type transducer? Definitely true, high power dissipation is there. Yes, signal to noise ratio is also high for this. Okay. And distortion, case of distortion, if you see, that is also high for these resistance type transducers usually. So answer is, anyways, any two are matching confidently, so you can say you have to go for all of the above most of the cases because option is there. Okay. Yes, Suresh, you're right. SNR means signal to noise ratio. Next question. These are some of the previous questions from different exams. Okay, they're pulled up here. So these might be, one of these might be your next question in an exam. So get ready, guys. I think, let me give one tip here. I don't know whether I should give it or not. One cheat code maybe. It's not that it'll always work. Most of the times it'll work. Okay. So the tip is, should I give it? Okay. Tip is, if you have in the option, suppose answer is suppose something, it's fine. If you don't know what is the answer, if you're confused, then in the options, if all of the above is there, then that could be most likely correct. Okay, in the options, if all of the above is there, most likely that could be correct answer. If none of the above is there, most likely that is not the answer. Okay, just give it a thumbs up if you like this tip. Okay, try to apply this. So apply this only when you don't know what exact is answer. Okay, don't blame me afterwards. And Tarun is smart enough in saying that plural is there, so it is all of the above. And the question normally they don't give is, they will give is or. Okay, smarter guy, Tarun. I'm still not clear on the previous question. Suresh, what is the previous question? Signal to noise ratio and these things, just go through potentiometer, you will get it. They're the basic points here. Signal to noise ratio is low, it is it? No, it is high SNR. That's why it is bad. Yeah, signal to noise ratio is high. So it is actually good. What's the point? Which of the following is a disadvantage of the resistive type transducer? SNR is high means it is actually good. You're right, dear. You're right. High power consumption, it is true. high SNR, but actually these resistance type transducers are not high SNR, to be more precise, because they're not having any filter characteristics within it. It is a resistance simply. It is a resistance simply. Its signal to noise ratio is worst performance because it's not going to have any frequency response. Signal to noise ratio means, suppose when the input is changing, okay, vibrating a little bit, that will also reflect over there. There is no frequency response, or there is no frequency filter kind of a thing for resistance transducers. Okay, so is it good to say, I think option should have been something like this: high distortion, this is right; high power consumption, this is right. Okay, so I think this should have been, who is that, by the way, who is asking this? Raz. So this is low signal to noise ratio is, should have been the answer. Okay, should have been the option, because these two are matching. There is something wrong with this, I think. Yeah, good point, by the way. Why I'm saying this? Because that resistance type is not having such filter characteristics or anything. All of the above, all of the above, all of the above. Please comment. What is that? To Raj B. High distortion cannot be there in the resistor. LDR. I think, what is LDR full form? Tell me. LDR full form. Tell me. What is LDR full form? This is also one of the questions in the previous. LDR full form, RTD full form, LVDT full form. These full forms they're asking directly, man. LDR full form? Yes, light dependent resistor. Okay, light dependent resistor. It has only two pins. And all these instrumentation lectures, most of PiSquare's instrumentation lectures are backed by experiments. Okay, because they can be experimented very nicely. They can be shown to you very nicely with the help of lovely experiments, and we did those experiments. You can just watch those videos in the course. Okay, next one. I think it's given already. It is also there. Light dependent resistance. And as we already seen this question earlier, let me add some more point with the help of this question. Yeah, tell me, if light intensity is increasing, what will happen to the resistance? Will the resistance increase or decrease with the help of resistance? With the help of light? Suppose this is light intensity illumination, and this is a resistance. This is a light intensity. So tell me the curve. It will be of which shape? Yes, it falls, it decreases exponentially. And what's the relation? What's the relation between these two? Resistance is equal to, I think we'll see that in the next questions also. In the next questions it is there. Okay. So I think there it will be better. Otherwise it will be leak off with the question. Yeah, go to this. Try to solve this. What is the effect on properties of LDR when light falls? When light falls, resistance changes. That's what light dependent resistor. The name itself is their lovely name. Light dependent resistor, or you can call it as a photoresistor. What is that? Photoresistors. Okay. So Tarun has said something. Okay. Next question. What will happen if we supply a voltage of 250 kilovolts to the terminal of LDR sensor? 250 kilovolts, my god, that's huge. Module will shut down, damage, module will not respond for the time voltage, or module will not function normally. It will be damaged naturally because it is not having such a high power handling capability. Okay, cannot apply such a high voltage. 250 kilovolts is much huge. So I think definitely device will be damaged. Okay, because the voltage withstand capability itself is not having such high voltage withstand capability. Okay, so yeah, next question. So it will be damaged here. Okay, ads, we'll see that. Raj is asking something. Will electron travel at speed of light? What is your answer? I think if you know power systems, there it is pretty much clearly given. The charge, at what rate charge will transfer. So accordingly it is yes. And if it is in the free space, it depends on the medium also. In case of cables, it's a different speed. But yeah, it is subjective to discussion. But yeah, in a way, if I had to choose only yes or no, I would choose yes. This is for Raj. If somebody want to share your comments, you can share. It requires supply. Absolutely, Suresh. You're absolutely right. Suresh, you're amazing. He has explained also nicely. What Suresh is saying is, what kind of sensor is LDR sensor? It is a passive sensor. Again, option is A. Passive sensor, as in active sensor means they generate some voltage. Give me some examples of active sensors or active transducers where they're generating the voltage. What are those? Tell me. Anything in your mind? LED is not generating, dear. LED will also absorb. Thermocouple, piezoelectric. Absolutely. Both are correct. Give it up. Give it up for these two guys. Raj and Suresh. Generator. Yes, generator. Very good. Srujana is saying generator. All of you give like for Srujana also, because generator is also a transducer. Don't forget that. Generator is also a transducer. Very good. Very good, Srujana. A battery is not a, yes, it is also, you can say it's a, it's transduction is happening, its conversion is happening, so it's a transducer. Very good. LDR 250 volts, if it is applied, then what will happen? See, when you're applying these voltages, what we normally do is, we connect a normal resistor in series with this LDR. Okay. So 250 volts when you're applying to this setup, 250 volts when you're applying for this setup actually, then it's not a problem. It's not a problem. Okay, that depends on what value you're keeping it here. Okay, it depends on what value of resistance you're keeping here. That's where you will get this voltage. Basically, these voltage ratings are specified by the manufacturers. For 250 kilovolts range, nobody does that. Okay. It will become electromagnetic waves, right? So it's a charge here. Charge, the speed at which the charge will transfer. Yes, you can say charge transfer is the speed of light. And in case of electromagnetic waves, it is true. Wave travel concept, when you see, that is also speed of light. Okay. Yeah. This is one of the experimental question. Let's see how nicely you're going to answer this one. Just now, in the previous question, I briefed it. Electron having mass, so it cannot. But the charge can transfer, right? Charge of an electron. I think, let me ask this question to our AI. PiSquare AI is there, right? So I'm just asking the same question to AI and we'll see what is the answer. Yeah. It's ai.pi2.n. Okay. So what's the question? What's the question, Ras? What's the question? We lost the question. Okay. Electron travels at light speed. What's the speed of? What's the electron speed in a conductor? I'm just looking for his answer. Bot is thinking, oh no. It is said, I'm sorry, I don't have specific information about the speed of an electron in a conductor. So I think we are not trained our bot set to this content. I think that's why it is saying it doesn't have a data of that. Okay. Anyways, if an LDR is connected to an LED and a 5 volts battery and is brought from the dark to light, okay, so we have an LDR, just an LDR. This is LDR. It is connected through an LED and a 5 volts battery is connected over here. Now this setup has brought from dark to light. When it is in dark, it has a high resistance. When it is in dark, it has high resistance. So high resistance is there, LED is not glowing. LED is not glowing. Okay. Because most of this voltage is appeared across this, so very less voltage is appearing across this, it will not glow at all. When you are bringing this setup into the light, then this resistance will reduce and it will start glowing. It will start glowing. That's it. So what will the state of the LED? LED will light up. It will lit. Okay. Antenna theory, if you are so specific, okay, let's clear this question with the help of AI only, because you're talking about antenna and all. So let's take the help of AI directly. Okay. As we have not trained our bots to that, let me use GPT-4, I'm asking this question to GPT-4. Okay, let's see what will be that answer. Electron speed in a conductor. So let me give the engine to GPT-4. Okay, let's use its own training data. The speed of an electron in a conductor is characterized by two different ways, drift velocity and Fermi velocity. Will this be, is this equal to speed of light? I'm actually chatting with this GPT-4. This says no. The answer from the GPT-4 is no. The speed of electrons in a conductor, both the drift velocity and Fermi velocity, are much slower than speed of light. The speed of light in vacuum is 3 into blah blah blah. The drift velocity in a conductor is, as mentioned, is relatively slow, on the order of millimeters per second. The drift velocity of electrons, it is said. The Fermi velocity of electrons within a conductor is much faster, which is in the order of 10 power 6. And it is also significantly slower than the speed of light. So neither value is in anywhere near to the speed of the light. This is what the GPT answer, okay, which is convincing. So I think in the question, normally what we tend to understand is the traveling wave with the help of our power systems knowledge. Okay, so we try to answer with that, but GPT says so nicely this one. Yeah, you may counter it with the help of GPT references. Let's see the live web data. We're trying to find out some references if there are something. Wiki has some reference. Wikipedia page is having some reference. There also it is said the speed of electromagnetic waves, which is true in case of power system. That's what we exactly have. V is equal to C by square root of epsilon r mu r. Yeah, this is actually true. C is the speed of the light. This is what the equation we use normally. That we say, if it is air, normal bare conductors, epsilon r is 1, mu r is 1, so velocity is equal to C. But this velocity is basically electromagnetic wave velocity of electromagnetic wave. But the question is about exactly electron according to Wiki. Drift velocity, blah 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 blah. Anyways, GPT is giving the references of this Wiki page. Okay, and the conclusion as per GPT is artificial intelligence is, it is no. Okay, that's good. Okay, I think we made nice use of GPT also. I think next time I'll try to come up with only wave travels, not electrons. Okay. Okay, next time we'll try to come up with GPT on live here itself. So we'll try to interact with that live GPT here. Okay. Good. And then we'll give it to you. Already you guys are trying it out, right? PiSquare AI bots, you're trying, some of you are experimenting. Okay. We are still feeding the training data to it. Okay, it's taking some time, obviously. But yeah, shortly, maybe we're planning for a new year. I don't know whether it's going to happen or not. Let's see. Hope for the best. And those who are following the WhatsApp channel, in the WhatsApp channel, you have it, right? For those people, I think you will get early access, so that we'll get to know in which direction we have to train those bots based on your queries. Okay, you're asking these kind of questions, based on that we'll try to train the bots like that. Okay, with that data, I mean. Anyways, that's it. That's end of this session of instrumentation and transducers. Okay, and as I said, MATLAB questions are there, MATLAB or Python courses, and what is a PLC industry automation. We are trying to come up with those courses. So we want your choice. What is your preferred choice? Accordingly, we'll try to launch those courses. And if you want to avail our video courses with animations and all, you can always visit our website, okay, which is courses.pay2.in. So that's it. That's end of this lecture. Thank you. See you in the next lecture. Have a good time. Bye-bye.